Find the derivative of x to the fourth plus y to the fourth quantity to the 3 halves equals 3x squared y squared. So we have an implicit equation here. It's an equation involving x and y that is not solved for y in terms of x. And it's not possible to solve for y in terms of x. So we will take the derivative implicitly. This is done by taking the derivative of both sides with respect to x, indicated by a prime on both sides. Now the left side's a power rule, so we'll start by bringing the power down 3 halves, leaving the inside alone, x to the fourth plus y to the fourth. Subtract 1 from the power, I will call that 2 halves, and then we multiply by the derivative of the inside to complete the chain rule. The derivative of x to the fourth is 4x cubed. The derivative of y to the fourth is 4y cubed times the derivative of the inside, which is y prime, to complete the chain rule. Every time we take the derivative of a y term, we will have a y prime due to the chain rule. Equals to, on the right side, we have a product rule. 3x squared times y squared. The derivative of the first, bring the 2 down, multiply it with the 3, 6, subtract 1 from the power, times the second left alone, plus the first left alone, 3x squared, times the derivative of the second, which is bring down the 2, subtract 1 from it, and then multiply by the derivative inside. We will once again have a y prime every time we take the derivative of a y term. We have 2 terms that have a y prime in them. One is here, though it has all of this to distribute on it, and the other one is here. We will want to put those together on one side, but before we do that, we have to distribute on the left side. So we have a 3 halves x to the fourth plus y to the fourth to the 3 minus 2, 1 half power, times the 4x cubed plus 4y cubed y prime equals to the 6x y squared plus, and then the second term on the right, the 3 and the 2 can multiply to give us a 6 x squared y times the y prime. Before we distribute on the left side, let's rewrite the 1 half power as the square root. It's usual to write it as a radical instead of 1 half power. And now we can distribute it on both of the terms in the parentheses here. The right side we will leave as is. Distributing it in, we will have the 3 halves multiply with the 4 on the x cubed. That will give us 12 halves. I will write the x cubed first, and the square root of x to the fourth plus y to the fourth. For the second term, when we distribute it in, again we have a 4 and the 3 halves, which will give us a 12 halves. And I have a y cubed and a y prime, and then the square root of x to the fourth plus y to the fourth equals to 6x y squared plus 6x squared y prime. The 12 halves can reduce to a 6 for both terms on the left. So that's a 6. That's also a 6. We will want to isolate the y prime terms. I have 2 of them. I have this one here, and I have this one here. Let's bring those together on the left side, and then everything else to the right side. So I will keep the 6y cubed y prime square root of x to the fourth plus y to the fourth on the left side, and on the left side I'm also going to be moving the 6x squared y prime subtracting it over. On the right side, we will keep the 6xy squared. And on the right side, we will also have subtracting over the negative 6x cubed square root of x to the fourth plus y to the fourth. On the left side, we can now factor the y prime out, leaving us with 6y cubed times the square root of x to the fourth plus y to the fourth minus 6x squared y equals 2, and on the right side, we'll leave it as is. We can now divide both sides by what's inside the parentheses on the left side to give us y prime isolated. That will be 6xy squared minus 6x cubed times the square root of x to the fourth plus y to the fourth divided by 6y cubed square root of x to the fourth plus y to the fourth and minus 6x squared y. There's a common factor in the numerator of a 6 and in the denominator of a 6, and we will want to factor those out because they will be able to cancel. There's a common factor of x in the numerator, and there's a common factor of y in the denominator, but those will not cancel, so there's no sense in factoring those out. Let's factor the 6's out. In the numerator, 6 times, we'll be left with xy squared minus x cubed times the square root of x to the fourth plus y to the fourth. And in the denominator, 6 times, and we will be left with y cubed square root of x to the fourth plus y to the fourth minus x squared y. The 6's can cancel, and what's left should be our derivative. Xy squared minus x cubed times the square root of x to the fourth plus y to the fourth over y cubed times the square root of x to the fourth plus y to the fourth minus x squared y, and there's our derivative, y prime.